Here we're given a slope field, which is this graph up above, and they want to know which of the following differential equations below would give us that graph. So differential equations, remember, is just fancy math talk for derivatives, which is what all of these equations are. These are all dy dx's. And slope field is really describing what we have up here. This is the graph of dy dx, which means it's the graph of a bunch of slopes. So what you're looking at on this graph are slopes. So they're drawing in the slope at those specific points there. To do this type of problem, generally what you want to do is you want to find a couple of points and you just want to try plugging them into all of these options down below here. That's just kind of the method that you're looking for. It's one of those unfortunate situations where it's kind of like 5 problems inside one. You know, the quicker you are with your mental math, the happier you'll be. So what points do I want to use? Well, the best points to use are going to be these points that have horizontal tangent lines. These are horizontal slopes. Remember, we're reading the slope off of those. And so what I know about anything that's horizontal, I know what the slope value is there. That's dy dx equals 0. On the points beside it, you know, sometimes you might need to use a point on either side to see if it's going positive or negative, but that's all you can read off of this. So on the right-hand side here, I know that that's a positive slope, so I should get a positive number out when I plug in that point, but I don't know what that number is. And on this other side, I know that's a negative slope, but I don't know exactly what it is. So the safest place to go are these dy dx equals 0 to start with. So the idea is to pick probably 2 points to start with. The points that I want to pick, when you look at your options here, I kind of want to skip to something that has a negative value in it for my y and a positive value in it for my y. So we're all along x equals 1 for this whole row here, right? For this whole column of horizontal slopes. So no matter what points you pick, the x value has to be 1 on all of them. But the y value can change depending upon which points you want to choose. Again, I just recommend choosing something without another 1 in it. 1s can do some weird stuff, right? 1s and 0s are always strange when you're doing this work because 1 to the 5th power is the same as 1 to the 105th power, right? So it doesn't change, and the same with 0. 0 to the 10th power is the same as 0 to the 1,000,000th power. So 1s and 0s can do weird stuff. So I would try to pick a point that doesn't have another 1 in it. So I'm going to look like I said down here. This would be 1, and then the y value is -2. That's my x, that's my y. And then I would pick this other point up here, something in the positive space. So again, 1, 2. So this would be my x, and this would be my y. And now our process is we're going to start taking these derivatives, these differential equations from below, and we're going to plug in these x and y values and see if any of them end up equaling what I'm looking for, which is we want the derivative value to be 0. So if I start here on A, I'm looking at that equation. So this would be dy dx equals x times y. So then plugging in for x, my x value is 1, my y value is -2. That equals -2, which is not 0, so that can't be my answer. And we just keep working down the road here. So now we're looking at B. So I get dy dx, excuse me, equals x times y minus y. So the x in this situation is 1 again, the y is -2, and then that minus -2 is going to equal, we end up with -2, a negative negative is going to give us a +2, so -2 plus 2 gets us 0. So that half of this checked out. And now we just need to go play the same game with the other points and see if this side checked out. So I come over here, and again, I'm going to plug in 1 for x, and this time I'm plugging in 2 for y, and then I end up getting out minus plugging in 2, and so I end up with 2 minus 2, that gives me 0, so that's a possibility right there. Now we know that B works as an answer because we got 0 out on both sides. So B is a good possibility right now. A is off the table, and we have to keep rolling through these. So not to bore you to death with this process, right? So dy dx is going to equal x times y plus y, plugging in 1 for x, plugging in -2 everywhere for y, and we end up with Negative 2 minus 2, that's going to get us negative 4. That's a bad answer, so C's off the table. Rolling on to D right now, so we're looking at this equation. We're going to end up getting out xy plus x, which is going to get us 1 times negative 2 plus 1, which is going to get us negative 2 plus 1 is negative 1. That's not going to work, so that's off the table. And then we go to this E option here, and we get dy dx equals x minus 1 to the 5th. Notice there's only an x in this. There's no y value here. So when I go to plug in my x value, I get 1 minus 1 to the 5th. That's 0 to the 5th. That equals 0. That's a possibility. Doing the same thing on the other side, what's going to be weird about this, right, is that the x value doesn't change even though the y value does, right? So that idea of the positive negative that we were hoping would save us from some weird stuff may not be happening here. So again, we get 0 to the 5th on this side. So now what you've got going on is you have two possible options for what this answer could be just based upon that first one. So right now we've got B and we've got E. And so unfortunately what that means is you need to pick another couple of points to plug in to see if you can tell the difference between them. So as I go to find my other points, what I want to do is I want to find a point, a position that has a positive slope and a negative slope. So when I go to look for my positive slope over here, and you're looking up and down a line. So like I said, I know that this has a positive slope right there. So that's going to be at the x value now of 2 and 1. Then I want to find out a negative slope along that same line if it exists. And so I would look down here and I would say, okay, there's a negative slope along the same line. And so for my negative slope, I want to see if a negative number comes out. This is now going to be the point 2 comma negative 1. And so what we're checking for here is we need our dy dx, our answer, to come out of those equations as a positive number on this side when I plug those in. And then my dy dx, when I plug it in on this side, needs to be giving me out a negative number, because negative means decreasing slope, right? Positive means increasing slope. The only two I'm plugging into are B and E right now because they're the only ones left. So dy dx at this x times y minus y. On this side, plugging in 2 for x, I would get 2, 1 for y, minus 1. I get 2 minus 1 is 1. That is positive. And that was what I was looking for, so that still checks out. And then playing the same game on this side, so dy dx equals x times y minus y, plugging in 2 for x, negative 1 for y. I get a negative here. So then I get negative 2 plus 1 is going to give me negative 1. And so what I got out over here was a negative, which is what I was looking for. So right now, B is still in play, and we have to go see what's going on with E, right? So we come back, we plug into our E equation again. So we're plugging in x minus 1 to the 5th. So in this one, we're going to end up getting out 2 minus 1 to the 5th. That's going to give us 1 to the 5th, which is 1. So this is positive, so this side checks out. Going on to the other side, dy dx is going to equal, again, x minus 1 to the 5th. I plug in my 2 here. I get 2 minus 1 to the 5th. That still equals a positive. That's not what I want on this side. This side needs to equal a negative. It needs to be decreasing. So that's not what I'm looking for. So I can throw away E now. These are those problems, I always say pace yourself on the test, pick and choose the ones that you can crush real fast and kind of roll through the test and get those out of the way. And that lends you time to come back to a problem like this. It's not hard to get this problem right. It's just time consuming because there's no other real, quick way to do it without a calculator. So it's a lot of mental math and it can eat up a lot of time, but not overly difficult once you've got a method for taking it down. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.